So hello world. Fluff is on screen, but I'm going to knock him off screen in a second because we are going to work on Bennu for just a minute or two. So enjoy the Fluffy. Hey Wayne. Oh look, he's looking right at the camera. Aren't you being such a good boy? Yeah. Do you want Cheerios for being such a good boy, buddy? Do you want Cheerios for being such a good boy? There you go. You get Cheerios for being cute. Oh, look at that, Puck! Puck, speak? He's like, nah. Pink's like, I heard that. Alright. And make it rain! So thank you for the bits, Wayne! And make it rain! So I'll let you guys watch Puck, because I don't think I have Puck and Bennu set up. But I'm going to work on Bennu for a little bit while the dogs eat the Cheerios, and y'all can enjoy that. I really just don't have it set up. Hey, Guido! Yeah, the stream's starting early, and in about 10 minutes, I'm going to attempt to start calling into the conference call, because we're going to be part of a teleconference, or we're going to listen in on a teleconference for LightSail 2. So to kill time, we're, I'm gonna have you guys watch the dogs while I mark Bennu. We're going to chat. So yeah, instead of our usual daily space today, we're going to do the teleconference, which I know it's a bit weird. Oh no, I didn't even check to see if the title was updated. What is the title? Paranor is awesome. But yeah, instead of our usual daily space of news and stuff, we're just going to do the telecon. Dr. Pamela is traveling at the moment, so you may get either me or her tomorrow. It's kind of up in the air. And Jandra says, oh, Daz is out at Spaceport America Cup College Sport Rocket Competition. That's actually pretty cool. Dr. Pamela is at the PSI Citizen Science NASA thing. I don't know the whole appropriate title, and I feel bad because I don't know the whole appropriate title. But that's where Dr. Pamela is. Alright, and doggies have left, so now we'll switch over to Bennu. Yeah, it is so 1980s, and I actually have to call in and give them my credentials and which room I want, and I'm hoping it'll work. I was able to dial into it, because I guess Google voice numbers don't always like to dial into certain 1-800 numbers, and that's what they provided us with, is a 1-800 number. So we're just gonna kind of see how all this goes. Yeah. And I think I already overmarked some boulders that should have been marked as rocks. That happens. This image isn't too bad though. It's really not. Let's see. 1, 2, 3. Yeah, that should be a rock and not a boulder. So let me fix that. Dude. Rock. Rock, rock. And there's the cat. The cat's been fed this morning, I swear. But if he makes an appearance, he just makes an appearance. But yeah, we're going to dial in as a teleconference using my Google Voice number. And I'm going to give them my credentials, which is literally affiliation, my email address, my name. Which I'm like, my email address, really? And that's it. That's all I have to do. And then we'll just listen in. I don't know if there'll be an opportunity to ask questions. I do know the teleconference is going to be about LightSail 2, which launches later this week in the rideshare on Falcon Heavy, which will be the 3rd Falcon Heavy launch. Which that'll be cool. That's more than 3 dots. Perfect. I can mark that as a boulder. So what's up, Fluff? Fluff's like, I'm gonna lay just off screen because I know that's how I get Cheerios. Oh, excuse me. Didn't mean to blast everybody's ears out there. So it's raining today, so I'm hoping my connection's going to be stable. It should. I don't trust it, but it should remain stable. There are worse things than hiccups. I think my dog's barking incessantly without me hitting mute is worse than me hiccuping once. DPI says, speaking about big heavy rockets from SpaceX, I haven't heard a lot about Starhopper lately. I have to like haunt Twitter to get Starhopper updates. I don't spend a whole lot. You'd think I'd spend a whole lot of time on the SpaceX subreddit. I do not. I literally pop in when I'm prepping for streams, and that's it. I don't know what's going on with Starhopper. They're probably still doing engine tests, but due to the nature of the tests, I really don't want to feel like I'm being held captive and you're being held captive by a stream to hopefully watch like the engines test fire. So Jean Derloon says there's a YouTube channel that streams Starhopper live nearly 24/7. Yeah, and that's what I mean by I don't want to hold you hostage by just waiting for it to do a test fire. So Lab Padre is that YouTube channel. Thanks for sharing, Chandra. Gem Doctor says, the rain is expected here in Vancouver too, but it hasn't started yet. Just remember, DPI, there were a bunch of people watching a live feed of a giraffe that was about to give birth. Thousands of people just watching this giraffe. So it was kind of a cultural sensation for a little bit. Heck, I went into an appointment and the person I was there to see was refreshing to see if the giraffe had given birth yet. Like in between her clients. I was like, wow. A lot of gravel. Alright, is anybody seeing anything that's blaringly missing? Ooh. Wayne Johnson says, I'm sitting in the ye old Miter Inn waiting for my astronomy club talk about Apollo 11 to start. Jean Derloon adds, there are people that watch bird nest cams. There sure are. I think one of the first live stream things that really took off was the coffee cam. I forget exactly what it's called. But I guess a bunch of scientists got tired of, or a bunch of people working in a lab got tired of going to the coffee pot and seeing that it was empty. So somebody set up a webcam and a little desktop app, and they live streamed the feed from the webcam to everybody's desktop so they could see whether or not the coffee pot was full. And people would just stare at this, just stare at it. It's kind of amazing. Yeah, the giraffe stream was pretty cute. Alright, I am going to submit this image, and then we're going to chat for about 5 or 10 minutes before I start dialing in. They said to start dialing in 5 to 10 minutes before the conference was to start, and I don't know how many people a minute, or how many minutes it takes per person to be processed into the conference, so... Oh yeah, okay, so it wasn't really live stream. Guido B corrects me about the coffee cam. It wasn't really live stream, webcam taking pictures every couple minutes or so. Streaming wasn't invented yet when the coffee cam started. No, the World Wide Web was in its infancy. World Wide Web is different than the internet. Internet allows you to connect everywhere. World Wide Web makes it easy for you to find where you're going. And that's the www addresses. So I'm going to click submit on this image. That one's actually not too bad. That looks like it's too small to be a collection site, but that looks like it might be a good collection site. All right. And where's the doggos? Transition. Local BBS. 2400 baud rate. Oof, 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 oof. All right. So, close Bennu. Hey, Zach, welcome. And YYZ's resubscribed. Can you go back to that previous image? I cannot. I hit submit, and it's done. It's done. I never want to think about it again. Hey, Falco, it's all right. So, here's the Cheerios. Puck's excited. Puck, speak? Oof. That's laying down. That's not speak. Tinker jumped off the couch. And make it rain! Well, I'm glad a bunch of us were able to do an image together. You have a question about the previous image. Yeah, www isn't really needed anymore, but that's where it came from, is finding the World Wide Web. Because before, I think you had to navigate by going to direct IP addresses or following links. Yeah. You did an image. YYZ says, I was lucky. I did an image. It had lots and lots and lots of big boulders. Falco online asks, is it important not to mark too small pebbles? Yes, yes it is. You do not want to mark anything that is less than half the size of the blue dot. So if it looks like a little speck, please don't mark it. There's gonna be tiny bits, but you really don't want to overmark. I know you're like, must mark all the things, but partially for your endurance and partially for your sanity and partially for our sanity and our data, don't mark the super small stuff. Just don't do it. You do get the hang of it. It's okay, Falco. That's why 15 people total look at the same image. So you have 15 people all looking at the same image, all marking the image. That's why it takes so long for one image to get done, is because you need 15 people to do one image before it progresses. So, and yeah, as DPI says, you get the hang of it after a few dozen images. You do get the hang of it probably after 5 or 10 images, which I know is a lot. Just kind of hang in there, stick in there, do it. I'm going to encourage you all to mark. I'll encourage you to mark during the telecon. Veronica says, when marking, I think, does Osiris Rex need to know it's here? It makes it easier for me. Yeah, don't do too many. You don't want to, I forget what you don't want to burn yourself out. I can only do 3 while I'm streaming, and I try to do them while I'm streaming. And I find that doing 1 while we're waiting for daily space or whatever to start is a good reminder for all of y'all to mark images, and B, it's kind of a good way to pass time instead of just staring at the empty dog corner. So, Guido says, "We're just all trained monkeys doing the bidding of the mighty asteroid Bennu. I'm sure it's laughing at us behind our backs." It probably is, honestly. Alright, so we're going to... We have like 4 more minutes before I'm supposed to call in. I kind of want to call in sooner. But I don't know if I can. And then I'll have to figure out a way to mute everything going to the telecon, but not to the stream if I want to keep chatting with you guys. Try it? Alright, I'll try it. Just remember, we were going to launch missiles with pigeons steering them. Just remember. Alright. So I should have made this a 2 thing. So I'm going to mute all the sound for a second. And don't panic too much. But I just want to... I don't want to blast my email out there for everybody because this email account doesn't get a whole lot of emails. And, yeah. So... You will see my lips moving. I will be muted. It is okay. It is okay, but there's the way I have it. Wait, there is a way I can have you listen to music while I do this. Hold on. I can at least let you listen to music. Alright. Let me do it this way. I think. Crap.
Thank you for calling. Please have your conference ID ready and a coordinator will be with you momentarily. If you require assistance during your program, please press *0 and a coordinator will assist you.
Okay. You should be able to hear me now. I'm assuming you guys can hear me now. Yes? You hear the hold music? Yes. Awesome. Cool. I just turned down the music. Yeah. Ducking. Ducking is amazing. Cool. So we're connected. They said we are going to listen to music until the conference call starts. So there is that. And I think I am going to have to overdrive like pretty much everything in order for it to be heard. So yeah, now we wait. Hooray! Yay! What are we waiting for? YYZ asks. We are waiting for the LightSail 2 teleconference. It is literally a teleconference. We are literally dialed in. We have the technology that I can do this on my computer, which usually is great. And I may actually switch headphones because this earbud is great for just hearing. Yes, please change the title. This earbud is great for hearing when alerts come through, but it's not great for hearing when people are talking to me. So actually, I'm going to do that now while I'm thinking about it. Simply because I want to be able to hear. So which one is this? It's this one. There we go. That's a lot better for me. It doesn't look as nice, I know, but I can hear. And hearing is important. Except now I need to figure out why I hear an echo. Do. No, it's not feedback from Discord. It's very quiet. Like I really have to yell to hear it kind of thing. I'm looking like a professional radio person. Yeah! Oh, you know what? I know what it is. Ha! There. It's because it was picking up my own voice in the telecon, and I forgot to mute. There we go. Do. No echo. Yeah, I fixed it. YYZ says, I met a couple of random people on the weekend who do Bennu mapping. Tagged one on Twitter for you since she's not comfortable with Discord. Cool. That's awesome. I probably should check my Discord more often. Another bad thing about these headphones is that it's not comfortable to wear glasses with them. So I don't know. Oh, for once you were up on the couch. Okay. Now we wait. Hey, Larry. Gem Doctor says I'm looking like a professional radio person. Yeah, I mean, I really like these headphones. They're a couple years old. Pretty cheapish Logitech headphones that work and have lasted longer than gaming headphones that I had previously spent a lot more money on.
To all sites on hold, we are currently checking in additional participants. We appreciate your patience and ask that you please continue to stand by.
The joys of moving. Yeah, you can ask a off-topic but professional question. I mean, we've got a couple minutes here before the conference starts. So as a reminder to everybody that was expecting to see Pamela today, I am obviously not Pamela. I am Annie, and we're not going to roll the rocket clip because I'm just too worried that it's going to get cut up. So Dr. Pamela is at a conference today. She does have a break at about this time, so she may or may not join us in chat. She will also be at a conference tomorrow. She should be back for Daily Space on Monday and Tuesday, and then after that it's kind of a toss-up. We're not sure if she's going to be able to stream.
All sites on hold. We are currently checking in additional participants. We appreciate your patience and ask that you please continue to stand by.
We're not sure if she's going to be able to stream on the Astro Tour. So she is at a conference at PSI, that's Planetary Science Institute, our host organization, for citizen science stuff. And I know I don't remember the professional name. So Falco asked, how did I set up Twitch? Riley has a channel for Numenta, but there's a huge delay. Is there something he can do about that? There's some settings in Twitch that do reduce the delay. If he's not, because I'm sure like we have a delay, but there's a way to set it up so there's even more of a delay than normal, and I wouldn't be surprised if affiliate and partner streamers get less of a thing. So I don't know if that really answers your question or not. Sorry, I'm just cleaning my makeup brushes. Oh, okay. But yeah, there's a way to reduce the delay. Another thing that we do is that my canvas is in 10. Oh wow. The delays between chat and display on your screen. It might be because he's not affiliate. It might be because he's not partner. It might be because of some settings he has. But another thing we do is that my canvas to set up OBS is in 1080, but I actually broadcast in 720, and that seems to help people. And the only times it really honestly does matter that we're in high def is maybe when I'm doing image processing. So kind of rearrange my workspace a little bit. And Twitch is indeed known to be twitchy. It really is. We've had all sorts of frustrations and issues and things of that nature. So yeah. As a
Please
side
stand
note,
by. Your program is about to begin. If you need audio assistance during your conference today, please press *0.
here we go.
Hello, everyone. Welcome. Thank you for joining us here at our LightSail 2 press teleconference. Our call is being recorded today, and we will have a copy of the audio in our press room at planetary.org later today. I'm so glad you could join us. I'm Danielle Gunn, Chief Communications Officer here at the Planetary Society. LightSail 2 is about to embark on a historic journey to become the first small spacecraft, a CubeSat, to demonstrate controlled solar sailing around Earth. Each of our mission team members here today will offer brief remarks, and then we'll open it up for Q&A. To ask a question in the Q&A, hit *1. We have with us today Jennifer Vaughn, Chief Operating Officer of the Planetary Society, Society's history with solar sailing and the story of the many space enthusiasts from all around the world who came together to make the LightSail program possible. We also have Bruce Betts, our Chief Scientist and LightSail Program Manager at the Planetary Society, and he will present some of the technical details of the spacecraft. Dave Spencer is our LightSail 2 Project Manager and Associate Professor at Purdue University, and he will share the mission operations plan. And Bill Nye, Chief Executive Officer of the Planetary Society, will give us an overview of solar sailing and the LightSail program. So we'll begin with our COO, Jennifer Vaughn.
Hello, it's so great to be standing here right now, ready to launch LightSail after all these years. So solar sailing in general has been woven into the DNA of the Planetary Society since before we were even founded. All three of our founders, that's Carl Sagan, Bruce Murray, and Louis Friedman, all had a hand in the early stages of solar sailing. So back when, in the 1970s, when Bruce Murray was the director of the Jet Propulsion Laboratory, there was an early study for solar sail. And Lou Friedman, one of our other founders, plus our executive director for the first 30 years, he worked on that mission. Like so many things, that mission got scrubbed, and at that point, the three founders got together and said, let's start the Planetary Society. And it wasn't mandated that we were going to pursue solar sailing, but it was a passion of all three of the founders. So our first project around solar sailing really started about 20 years ago with our Cosmos 1 solar sail. So that mission would have been the very first space test of a solar sail. And it was a partnership between Russian space agencies and Cosmos Studios, which is Andrew media company. So the three partners worked together and created Cosmos 1, and it launched in 2005. And sadly, the launcher failed, and we ended up in the Barents Sea, and so never had the opportunity to fly. So at that point, we went to our members, our supporters, and said, what do you want us to do? We've just put all these years and all this money into a solar sail spacecraft. What's our next move? And they came back with a resounding, try again. We really, really want you to try again. So with that, Lou Friedman, who was still helming the organization at the time and was helming this particular project, worked with Andrew to get some seed funding for new study for design concepts. And out of that study came this idea of using small sats, hardware, and trying to marry longer-term propulsion with small satellites. And that was the beginning of LightSail. So this started about 10 years ago. So we have all these nice round numbers happening, 20 years ago for Cosmos 1 and 10 years ago for LightSail. And now all these years later, we are finally ready to go. We had a major milestone in 2015 when we tested the LightSail spacecraft. We called that one LightSail 1. That was purely a deployment test. We sent the CubeSat up. We checked out the radio, the communications, the overall electronics, and we deployed the sail. And we got a picture of that deployed sail in space. There was no solar sailing that took place in LightSail 1. That was simply a deployment. So all has really been leading up to this point right now. We're ready to launch on Monday, we hope. And this time we will actually be pursuing solar sailing. So you're going to be hearing a lot more from others about solar sailing, about this particular project. But I want to note that one of the things that makes this project so distinct and so extraordinary is how it was funded. So this is a paradigm shift. This is maybe a new way of pursuing spaceflight projects. This $7 million project has been 100% funded by individuals. These are people who are passionate about space, people who want to do something to advance space exploration, and were willing to put their own personal dollars behind a project, not just at one time, too. It was over 10 years. So these are people that understand the complexity and the patience that you have to produce a space mission. So with this, it couldn't be done without our supporters, with our more than 40,000 people that have supported this mission, everything from $5 to more than $1 million. And this is their spacecraft. So we're so excited to thank them and have their spacecraft finally fly, and excited to be with you today so we can talk more about it. So back to you, Danielle.
Thank you, Jennifer. And now our CEO, Bill Nye, will give us an overview of solar sailing and the LightSail program. Bill?
Thank you, Danielle. Greetings, everyone. Thank you so much for taking the time. Now, I was in Carl Sagan's astronomy class 42 years ago. And he talked about solar sailing, and he had a model of a solar sail that was going to be all three of the founders involved in. Lou Friedman's an old orbital mechanics guy, and was going to catch up with Comet Halley, what we used to call Halley's Comet. And the mission got canceled in favor of the space shuttle program and the space station. But it really goes back to the 1600s. Johann Kepler, the guy after whom Kepler's laws of planetary motion are named, was watching Comet Halley before it had that name. And he reasoned that whatever was causing the tails to form must be something coming from the sun. And so he speculated that brave people would one day sail the void and so on. It's really a romantic notion that Sagan promoted during his class, and it was really something. So as you may know, I joined the Planetary Society when it was formed in 1980. And we've been talking about solar sails around here ever since then. And when the CubeSat design emerged sort of organically in the spaceflight community, something that surprises many people at first is there are a lot of sharp edges on spacecraft because there's hardly any air in space. And so the CubeSat led to a square sail. And the square sail turns out to be a pretty good starting point, a pretty good design. It has to have rigid booms. We use the term boom just like on a sailboat to hold the sails out because we're twisting relatively fast in Earth orbit so that we go edge on toward the sun, twist 90 degrees, go face on and get a full push like a sailboat going downwind and building orbital energy, then twisting again on the night side of the Earth and twisting on the day side over and over. For this LightSail 2 could be up for about a year, depending how big the atmosphere gets, depending on solar activity. So it's really a romantic notion, everybody, that has tremendous practical applications. There are just few missions solar sails are absolutely ideal for. Wherever you have to keep station with the Earth, orbit at the same speed as the Earth is orbiting the sun, but at a different radius, at a different orbital distance. Solar sails are just ideal. And people have speculated on using solar sails as cargo ships to take material to Mars and so on. But what we do at the Planetary Society is advance space science and exploration, and LightSail 2 is a big part of that. And whenever you see another organization involved in solar sailing, and it's a small group, people use a representation that's very similar to LightSail 2 because we hired people, we are involved with people who are on the forefront of engineers and scientists who are on the forefront of this. And so we share the technology with the world. And we are very excited about this launch because we're going to get to a high enough altitude to get away from the atmosphere far enough that we're really going to be able to build orbital energy and take some, I hope, inspiring pictures and include people around the world. We have a disc on, a compact disc, compact disc with everybody's signature and pictures on it. People from around the world who funded this thing, who just think that solar sailing is a fantastic idea and they want to be part of advancing space science and exploration. So thank you all for listening, and we look forward to taking your questions. Back to you, Danielle.
Thank you, Bill. And now we have Bruce Betts. He's our Chief Scientist and the LightSail Program Manager, and he will present some of the technical details of the spacecraft. Bruce?
Hi there, and thank you all for attending and listening to this. We're super excited about LightSail 2 and its upcoming launch. So what is LightSail 2? As Bill mentioned, it's a CubeSat. It's a so-called 3-unit CubeSat. It is about the size of a loaf of bread. And out of that comes a solar sail of 32 square meters that is about the size of a boxing ring. So one of the big challenges in creating LightSail and LightSail 1 and 2 was to figure out how to cram all that stuff into a little tiny spacecraft. One of the key things that LightSail 2 is trying to demonstrate for the first time is that you can do solar sailing with a small satellite, a CubeSat, that it is viable, that we can control the solar sailing. So the mass of the spacecraft is 5 kilograms, and it has 3 basic configurations. So shortly after it comes out of the Georgia Tech spacecraft Prox-1, it's basically that loaf of bread with a little antenna popping out of it. And then a few days, Dr. Dave Spencer will talk about exactly what we're going to do with these configurations in solar sailing. But a few days after we deploy from Prox-1, we will open the panels on the side of the spacecraft. And on those are 2 fisheye cameras that will capture images of the sail deployment and images of the sail. And then, of course, we have the deployed sail, 4 triangular mylar sails that will deploy using 4 booms, which Bill mentioned, which are all made of cobalt alloy called alloy. Let me mention a few of the other parts of the spacecraft. We, of course, have solar cells covering the outside of the loaf of bread, but also the insides of the panels that deploy. Batteries, of course, avionics, so the computer brain of the system as well as other electronics, and then a number of pieces that are designed primarily for our controlled solar sailing, but also just orientation attitude of the spacecraft, so detectors, gyros, magnetometers, and then we have magneto-torquers that use the Earth's magnetic field to make small adjustments to the spacecraft orientation, and a momentum wheel that's spinning, and we can spin it up and down, and that'll cause the rapid slewing of the spacecraft that Dave will talk about. We also have small corner cube reflectors that the International Laser Ranging Service will attempt to hit with lasers and measure, therefore, the orbit very precisely if that works out. And then we've got the mini DVD that Bill mentioned that includes the names of all of our members, all of our Kickstarter backers, and people who submitted through our website both names and also pictures, selfies going to space. So I'll finish up with just commenting that in its own way, this is history in the making. LightSail 2 is going to fundamentally advance the technology of spaceflight, particularly by demonstrating solar sailing as a viable option for a small, standardized CubeSat spacecraft. Thanks. Back to you, Danielle.
Thanks, Bruce. And finally, we'll hear from Dave Spencer. He is the LightSail 2 project manager. He's also associate professor at Purdue University, and he will share with us the mission operations plan. Dave?
Thanks, Danielle. Hello, everyone. So we're really looking forward to operating this mission. So LightSail will be the first spacecraft to use solar sailing to increase its orbital energy, pumping up its orbit using sunlight alone. And I want to walk you through some of the significant events that will unfold during the course of the mission. So when the spacecraft is launched, LightSail 2 is actually buttoned up inside of the Georgia Tech Prox-1 spacecraft. The Space Test 2 program, the launch, Falcon Heavy, is going to launch a couple of dozen small sats into orbit. And so Prox-1 and LightSail 2 are just 2 of those payloads. Will be deployed into an orbit that's 720 kilometers altitude, near circular orbit. That's about 450 miles above the Earth's surface. And once it's deployed, Prox-1 is just going to be waiting. It's going to wait for a week to allow time for all of those vehicles to spread out Ground operators will be tracking the spacecraft so we understand which of those vehicles is actually Prox-1. 7 days into the mission, Prox-1, driven by a timer, will actually deploy LightSail from a deployer device. LightSail will separate from Prox-1 and drift away. At that point, the LightSail 2 radios will turn on, and if all goes well, we'll be able to acquire a radio signal from LightSail 2, start checking out the spacecraft, making sure that all of its subsystems are working properly. In particular, we'll be looking at the power situation on board the spacecraft, making sure the power system is working properly, establishing communications, making sure that we can send commands that are received by the spacecraft. And then we'll go through a systematic checkout of all the various subsystems. As Bruce mentioned, we'll be checking out the cameras on board. Even with the solar panels closed, enough light sneaks in that we'll be able to take pictures with those cameras and make sure that they're working properly. We'll check out the attitude determination and control system, making sure that the spacecraft can understand what orientation it's in and control this orientation properly. One element that we do have on the spacecraft that we did not have on LightSail 1 is a momentum wheel, which allows us to rapidly change the orientation of the spacecraft. And we're actually going to do something of that in the initial configuration with the solar panels still closed, make sure that we can change the wheel speed of that momentum wheel. And we'll also put the spacecraft into the same mode that it's going to operate in when it's solar sailing. The software that's going to be used for controlling the sail, tacking, we'll actually check that out in the stowed configuration before we deploy the solar panels and later the sail. So that checkout period will take about 4 days. Then we'll deploy the solar panels. As Bruce mentioned, the cameras are mounted on the tips of those solar panels. We'll take some additional images, make sure that they're still working properly, make sure that with the panels deployed now, we should be getting more solar energy, and we want to make sure the power system is stable. That should take about a day, and then we'll be ready for our big event, which is solar sail deployment, which will take about 2.5 minutes to roll out those booms and unfurl the sail. And the spacecraft, if all goes well, will immediately go into that solar sailing mode that Bill Nye mentioned, where when the spacecraft's moving towards the sun, it's orienting the sail edge onto the sun. When the spacecraft's moving away from the sun, it makes a turn and puts the sail face onto the sun, so it's getting that maximum push from the solar pressure. And over time, that gives us a raise to our orbit. We're increasing the orbital energy, which should be very measurable. And so that's really the big thing that we're trying to get out of this, is demonstrate for the first time solar sailing in orbit propelled by sunlight alone. Back to you, Dan.
Thanks, Dave. Okay, everyone, we will open things up for Q&As now. And a reminder that to ask a question, you hit *1, and then you'll be introduced with your name and affiliation.
And again, that is the star and 1 keys to ask a question. We'll take our first question from Scott Snowden with Inverse. Please go ahead.
Hi, Jennifer, Danielle, David, Bruce, Bill. It's great to speak to you. Congratulations on this amazing achievement, and I wish the mission the very best of luck. The fact that this was crowdfunded could really change things. It could increase the size and scale of understated scientific missions. Would the Planetary Society consider this any other so-called stuff of sci-fi research projects?
So I'll start here, and if anyone wants to jump in, they can. This is Jennifer. So we've always been about kickstarting kind of seed funding new technologies. So things that are cutting edge, that are just in the early stages of being tested. And that's really how we tiptoed into solar sailing to begin with, was we had some smaller opportunities that turned into bigger opportunities. And then before we knew it, we were doing our own mission. So the organization is going to continue down this path. And we are currently supporting some technologies, some different science projects and science and technology projects. And then starting in 2020, we're going to start an open proposal process, a competed proposal process, to really open it up to the world for ideas. And from that, we're really hoping to really democratize this process of getting the best ideas into the hands of the people that could potentially make these dreams into reality. So we think that this is just the beginning. Since we were able to get to this point, this is quite the accomplishment to say that we were able to complete this project using all crowdfunding. now that we've gotten here, we're looking to the next horizon ultimately. Does that answer your question?
Yes, it does.
The short answer, Scott, is yes. This is our business. Is engaging people around the world. Well, engaging people around the world in advancing space science and space exploration. Because as I so often say, space brings out the best in us. It's where we solve problems that are never addressed before, and it just really appeals to people of all political orientations and nationality. So it's exciting, but this is a big step. I mean, LightSail, this could be a game changer. So we're excited. That's a great question. So back to you, Danielle. Sorry.
Thanks, Phil.
Thank you.
We'll take our next question from Daniel Oberhaus with Wired. Please go ahead.
Hi, thanks for taking my question. Looking to the kind of far future prospects of this technology, you often hear LightSail discussed in the context of interstellar travel. And I was hoping you could kind of just break down how that works, because I guess intuitively I'm thinking about this, and it seems like the solar flux would be so small even by the time you get to the outer edge of the solar system, that you would just need an absolutely massive LightSail to make that work. So could you kind of discuss how that would work, and also what altitude you're hoping to hit on this mission?
Well, let me say, first of all, the premise of the bit in interstellar travel, really the only way to do it that anybody can think of right now is with solar sail. But you push it with laser light, either Earth-based lasers or people have proposed putting lasers on the moon to push the solar sail. To your point, the solar flux gets to be pretty spread out. Also, people have proposed using radio energy with an enormous sail made essentially of wires that would get a push from another frequency of energy emitting from the sun. But the idea is to use a laser to push it. So I'll let other people who I think are more expert in this take it from here.
One other comment. This is Dave. A lot of the missions that have been conceived to use solar sails that go to the outer edges of the solar system or beyond the heliopause only use a solar sail during the early part of the mission when they're near the sun. And you're right, Daniel. When they actually get to the outer solar system, most of these mission concepts drop the sail off to get rid of that mass, unless it's useful in terms of power production or something like that. But if you are going to go interstellar, as Bill said, pushing the sail along with lasers is a viable option. I think you also asked about the orbit altitude. So we're going to start at 720 kilometer altitude, circular orbit, and through solar sailing, we should be able to increase our orbit altitude on the order of 0.5 kilometers per day. Now, that's based on simulation, and that's assuming everything goes perfectly. So really, if we get a measurable increase in altitude on a regular basis and see the apogee, the far point in the orbit, increasing over time, that's a win for us. That's what we're trying to do.
Does anyone else have anything to add?
Well, something that's always charmed me, I'm a mechanical engineer, and I've spent actually quite a bit of time when I was a young guy sailing. But I've been to these meetings with guys like Dave and Bruce Betts, Dr. Betts, and there's debate about what will be the shape of the sail when the sunlight's hitting it. It's people in sailboat design agonize over the cut of the jib and so on. And so people are not sure. Nobody's really agreed on what's going to be the shape of the sail. Will it billow like a square rig ship? Will it take on a nice curve like a racing jib? Will be something in between. And we really do distinguish between the effects of both wrinkles and crinkles. And this, I cannot help but hearken to the words of test pilot Tex Johnston, who said, "One test is worth 1,000 expert opinions." So this is one of the really, to me, really exciting and for me, fascinating aspects of the LightSail 2 mission. We're going to see what really happens as we try to increase orbital altitude. You know, Dave mentioned that we've done all sorts of mathematical models, but we're going to see how it really works.
Thank you. We'll take the next question.
And again, that is the star and 1 keys to ask a question. We'll next go to Victoria Barilla with Seeker. Your line is now open.
Hi, thank you so much for taking my call, and congratulations on the LightSail 2 project going up. I just wanted to ask if each of you can elaborate on what motivated you to help pioneer solar sailing and what this LightSail project means to you.
Sure.
Well,
I guess I'll start. Okay.
Well,
no, you can
I'll hand it off to you.
Go ahead, Bill.
I mean, I was introduced to this idea during the 1970s, during the disco era. And then as a member, just receiving the mail before I was asked to be on the board and before I left the room at a board meeting and they took a vote and made me CEO, I bought Lou Friedman's book about solar sailing. And I just thought it was just a fantastic idea. You know, it gets into this thing. There's no fuel. Once you're on orbit, once you're out of the exosphere or real high above the Earth's atmosphere, you can just get propulsion to all sorts of destinations in the solar system. And there are 2 questions everybody asks. Where did we all come from? And are we alone in the universe? And if you want to answer those questions, you have to explore space. And part of that, really, you guys, is exploring asteroids, Mars, and Europa. If we found evidence of life on one of these other worlds, it would change the course of human history. And how are you going to get there? How are you going to send a spacecraft, especially to an asteroid, to look for primordial minerals? You're very likely you're going to use a solar sail. And indeed, the NEA Scout mission, Near-Earth Asteroid Scout mission, which is a NASA mission planned to fly on a Space Launch System rocket, that's a solar sail, which is in many ways similar, especially the deployer mechanism, very similar to LightSail 2. So this thing grabbed my heart in the 1970s, and it's still with me, and I'm very excited about this launch. Take it, Jennifer.
Okay, so I've been with the organization for a little bit longer than this whole process with projects. I've been here more than 20 years. So I feel that having this active solar sailing project is such a part of my relationship to my day-to-day work with the Planetary Society. And it feels like we've been slowly, just step after step after step after step, working toward this moment that is finally going to occur. So for me personally, it feels like any other major life milestone, like graduating from college or something, that you've really worked for this moment and you're so excited for it to happen. But you also recognize at the same time, it's really the beginning of a whole new chapter as well. So we are so excited to come to completion with this project and to test it out and to learn from it and to share the results. And so we're not yet done with LightSail, but at the same time, there's this newness ahead of us of what now for us. There's an opening. And when it comes to these kinds of technology or science and technology projects, what excites me so much is how it resonates with the members that we serve. So again, these are people that are just passionate and want to use their passion to do something meaningful. And to be able to deliver on that is so fulfilling, to be able to say, we took your passion, we took your money, and we turned it into something that is really meaningful for the advancement of this particular technology, but also in these other ways that we've discussed, these ways of funding, of bringing people together to support emotionally as well as financially. So that's what it means to me personally, but that's also what draws me to solar sailing, is the fact that it's so wonderfully connected with our members and got them passionate.
This is Bruce. It's incredibly rare that one gets an opportunity to participate in the first stages of a new spacecraft propulsion technology. There aren't that many. So being at the initial phases, first steps of solar sailing is quite an honor, and particularly when combined with CubeSats and their prevalence among universities and agencies in Earth orbit, and then now doing something that, because it doesn't require fuel, could help facilitate more interplanetary missions, different kinds of space missions. It's all very exciting. Thanks.
And this is Dave. I got involved with the LightSail program almost 10 years ago. Lou Friedman gave me a call and said that for LightSail 1, they had a review and they wanted to bring in somebody who had significant mission operations and development experience, and asked me if I would join the team. And the thing that's been really fun over the last 10 years is working with such a small team. I mean, you need to understand, this is just a handful of people that have pulled this together. The Planetary Society and Ecliptic Enterprises, our space system contractor, Boreal Space, a little company in Silicon Valley, Cal Poly and Purdue, using university faculty and students. It's really just a handful of people that have pulled this together, and it's kind of daunting at the same time, but we're really looking forward to flying it, and it's been a great experience. Back to you, Danielle.
Thank you. We'll take the next question.
We'll now go to Devin Koldewey with TechCrunch. Please go ahead.
Hey guys, thanks for taking the time to talk. On LightSail 1, you guys extended the sail about 90%. Are you planning on stretching it out further this time, and what went into that? And could you characterize the magnitude of the force you're expecting to be exerted on the sail, just compared to another form of propulsion, so we kind of understand the difference in magnitude? Thank you.
Bruce or Dave?
Bruce, do you want to handle the sail deployment aspect?
Sure. Actually, I'm sorry. I lost track between the two questions. I lost track of the first question.
I'm sorry.
Repeat your question, Devin.
Yes, I'll just do the first one first. On the original LightSail, or LightSail 1, you extended the sail about 90%, I think. And are you planning on extending that to the limit this time? And what went into doing that?
Yeah, so we had various simulation tests and deployment tests at Cal Poly San Luis Obispo of both LightSail 1, but then LightSail 2, and have better defined the exact motor count, how many revolutions of the motor we expect to do a full extension of the sail. So we do plan to extend it to 100%, but we also have the capability on orbit, if it looks like it's not fully extended, we can extend it a little bit more. We also put some fiducial marks, some markings on the booms to help us have a better handle on exactly how far out it is extended compared to LightSail 1. So we will have more control this time around with that. Thanks.
Yeah, and in terms of the amount of force that solar pressure is going to exert on us, it's in the micro G level. Micronewton level. So it's very tiny compared to chemical propulsion, or very small even compared to electric propulsion. But the key is, for solar sailing, it's always there. So even though you're at the micronewton level of force, that level of force is always there, and you're able to use it to accelerate the spacecraft and go where you want to.
Now, one of my favorite, I have many numbers that I love, but it's 9 micronewtons per square meter. So if you have 32 square meters, you get, about 100 micronewtons. And it doesn't sound like much, but as Dave points out, it's continuous. Once a rocket engine runs out of fuel, it's done. But solar sail gets a continuous push day and night. Wait, there's no night. Well, actually, there is for LightSail 2. There's going to be on the night side of the Earth for 45 minutes. But it's just it's so different from what we're used to in rocket science. Newton's first law: things in motion tend to stay in motion. Yeah, when the rocket engine stops, they stay in motion. But with LightSail, there's a continuous acceleration. Back to you.
Let me just add real quick, this is Bruce, that the total force on the sail is approximately equal to the weight of a housefly on your hand on Earth, to give you an idea how small it is. But again, the key is that it's constant. It's always there.
Excellent. We'll take the next question.
And we'll now go to Aylin Woodward with Business Insider. Please go ahead.
Hi, thank you so much for taking my question. I had a brief query about what the expected brightness might be and where to maybe go to track visible passes if we can indeed see it at night from the ground. And if we can't, you can also elaborate on that as well.
This is Bruce. I'll take a first stab at it. First of all, we're in a much lower inclination orbit than LightSail 1 was, so we're in about a 24-degree inclination orbit. So we don't expect it to be visible beyond about 42 degrees north latitude or 42 degrees south latitude. But within that range, the brightness is going to vary considerably. So during the first phases of the mission, where it's before the sail is deployed, it will be incredibly dim and hard or impossible to see. Once the sail is deployed, the challenge is that it very much depends on orientation. So if it's edge on to your viewing point, you're not going to see anything. If you happen to catch a specular reflection directly to you, then it's going to be incredibly bright, much brighter than the brightest star. But it's going to be highly variable depending on orientation. Did anyone else want to add anything?
Well, a story I've told many times. I went out looking for LightSail 1 maybe a dozen times. It has to be flying over you when the Earth is oriented just so. It has to be a combination of the spin of the Earth and the orbit of the spacecraft. But almost on the last day, it would be visible. I was on the roof of an apartment building in New York. And what we provide on our website is a system we call LightSail Above. And you can put in your latitude and longitude, and it will tell you where it will be in the sky. And the key for me was, there's apps for your mobile phone that are like a compass, give you an azimuth. And I just couldn't get over how accurate it was. I looked right where it was intended, it was supposed to be, and there it was. And this is in New York City, where there's a tremendous amount of light pollution. And it was maybe 20 degrees above the horizon, but I could see it, man. And I watched that thing go. I left to right for almost 10 minutes. It was just riveting, and for me. And Carl Sagan talked about this. If you get something this shiny, you'll be able to see it from the Earth's surface, and indeed you can. And so this will be up about a year. So it's very likely that people who don't live too far from the equator will get more than a glimpse of it more than once. I'm very excited about it.
Wonderful. Thank you so much.
And we will now go to Megan Bartels with Space.com. Please go ahead.
Hi, thanks for taking my question. Can you hear me?
Yep, you sound great.
Great, thanks. So I wanted to ask about what would come next after LightSail 2. Do you already have sort of the LightSail 3 version in the works and you're waiting to get data back to sort of tweak it, or are you completely holding out until you see how this one goes?
Bill?
Oh, I thought Jen would jump in.
No, I'm happy. I'm happy to jump in. So, yeah, we'll hand it to Bill. There's no plan for LightSail 3. But that's because we're not a LightSail company. So it's really important to remember that we are an organization. We're a membership organization. And our members are enthusiastic about a lot of things. And we have been doing we've been doing solar sailing for a long time, and there may be an opportunity. We may find that there is a great opportunity to get involved with yet another project involved in solar sailing. But it's more likely that we'll get involved with other types of science and technology development. So what we're really looking for now are new ideas. LightSail 3 is for other people to take on, not necessarily with that name, but what we try to do is we try to get a technology ready to then hand off to the world and then it be implemented by others. And so right now, NASA is implementing this technology. And in fact, I think Bruce and Dave can talk more about their interaction with us. So we've been sharing information with them for their NEA Scout mission, which is using a very similar design. We hope to see other people adopt solar sailing and to continue to test this new technology. Why don't I pass it over to Bruce and Dave just for a moment to talk about NEA Scout and any other connections that we have.
NEA Scout, this is Bruce. Near Earth Asteroid Scout is a NASA mission scheduled to launch on the first launch of SLS, and we've been in discussions with them for many years, and we share information and data with them. They will be flying a 6U CubeSat, so 2 loaves of bread stuck together, and we'll have science instruments on board. So it is a logical follow-on with a somewhat larger sail to LightSail 2, and we do have a Space Act agreement with NASA to coordinate sharing of information materials. We also are all about sharing information more broadly, so we will put information out about the mission publicly, we will attend technical conferences, present papers, and share with the world. Dave, did you want to share anything more?
Just add a couple of things. First off, the NEA Scout team has been following us. You know, they've been coming to our major reviews and also coming to some of our deployment tests. So we've had a very positive interaction with them. And you know, this LightSail program has really been intended to advance solar sailing technology to the point where it can be used for actual space science missions, getting beyond the tech demo stuff and actually doing science. And that's what the NEA Scout program is doing. It's using a solar sail to go out and do solar system science. And so we're very excited to have been a part of advancing the technology to enable a mission like that.
I mean, everybody understands the solar sailing community. I get the impression that very few of you are planning to come to the International Solar Sailing Symposium in Aachen, Germany, which to me is just weird because it's just the greatest party ever. No, it's a bunch of scientists and engineers who are involved in this, and we share information. We go to each other's meetings because the subtleties of this thing are, I guess for me as an engineer, just a little surprising. You know, the NanoSail D was a NASA mission that was intended, or did, it used a sail to drag a spacecraft out of orbit. Because deorbiting, as it's called, is a serious problem. You know, we have a cluttered low Earth orbit environment right now. But NanoSail D didn't deploy for 5.5 weeks, and no one was exactly sure why. And so this is the kind of thing we come and discuss. I mean, people have very good hypotheses about what happened, but we addressed that with LightSail 1 and LightSail 2. We are not going to have that deployment problem. So as I mentioned it just as an example of something I was involved in, that the nature of the solar sailing community. We all know each other and we all share information, and it really is, I've said it as much as I can, it's really exciting to be flying this thing at last. It's almost 2020, and we've been talking about it for 40 years. It's very, very cool. Back to you guys.
Thank you. We'll take the next question.
And our next question comes from Neil Patel with Popular Science. Your line is now open.
Hi, thanks all for taking this. My big question has to do with kind of what you guys believe might be the one or two of the most major obstacles that the mission might run into. If there's an example or two you can kind of provide some detail on about how you guys have sort of planned out the mission design and execution to avoid, what might go wrong and that kind of stuff?
This is Dave. I can take an initial cut at that. For me, the thing that's new in this mission, which is most likely to give us difficulties, is the actual control of the spacecraft during solar sailing itself. So after we get the sail deployed, and we actually are orienting the sail relative to the sun, the spacecraft has to know what direction it's pointing. So it has to have what we call attitude knowledge. It needs to know its orientation in space. It's a low-cost spacecraft. We've got very low-cost sun sensors. We have low-cost magnetometers that are on board, and those things have to work properly in order for the spacecraft to be able to control itself properly. I do think that the momentum wheel is going to work fine. We've done a bunch of ground testing with that. So assuming that we know what our attitude is in space, I think the spacecraft's going to do the right thing. But that's really where the risk is. Compared to LightSail 1, we've done a ton of testing on this mission. The team has really been working over the last couple of years going through what we call day-in-the-life testing, basically testing every function that the spacecraft's going to need to do during its entire mission lifetime. And everything from solar panel deployment to sail deployment to controlling the orientation of the sail. We've improved the flight software significantly. We've improved the attitude control software significantly. We've added some fault protection software to our electrical power subsystem so we can detect if the power subsystem isn't behaving properly. So this mission is going to be much more robust than the previous LightSail 1. But, as we said previously, it's done by a small team. We've had a very small budget relative to our NASA counterparts, probably 1/20th of the budget that a similar NASA mission would have. So, it's a high-risk mission, but it's going to be high payoff also. That's all I have on that.
This is Bruce. I'll just add one thing. That was a great answer. Testing. We also have added both in software and hardware timers that basically check that things are working right, and if they aren't working right and they don't see that we're communicating with Earth, they'll restart a process or even reboot the spacecraft without ground input. Basically, on the concept for spacecraft is similar to your computer. Sometimes it needs a reboot to work better, and so we've got onboard intelligent software looking for things as a hardware timer. Thanks.
Bruce or Dave, just can you guys comment on the role of cosmic rays? That always fascinated me.
Just one comment about LightSail 1. So LightSail 1, we did not have that backup timer that reboots our spacecraft on a regular basis. And so we did go into a faulted mode where the spacecraft had latched up. And fortunately, we did get a cosmic ray that introduced a natural reboot of the spacecraft that allowed us to go back and regain control of the spacecraft. We now have software that's going to make that unnecessary. But we are susceptible to radiation, and has the potential to cause reboots, has the potential to mess with our software and hardware components. And this is a small set. It's a CubeSat. We don't have radiation-hardened components on board, so we are susceptible to that.
And understand, to put radiation hardening on a spacecraft like this would make it too bulky and too heavy. The trade-offs, you'd come out, you couldn't do it. So it's optimized for the environment in which it's going to fly. Back to you.
Okay, I think we'll take the next question. Thanks.
We'll take our next question from Stuart Dambro with IEEE. Please go ahead.
Yes, thank you. So a large segment of my question was answered to some degree when the 2013 potential for a LightSail 3 was asked. However, my question has to do with material. Right now, you're using, as I recall, a 4.5 micron mylar sheet. But there's been research for quite a long time, as I'm sure you all know, into using graphene sheets for the sail. And even though they are sensitive to UVC in some ways, it can have a negative impact on the graphene nanoplatelets in the nanocomposite films. If you were to, given all that said, but its strength and its nearly two-dimensional geometry and so on and so forth, and its versatility, if you were to look into a LightSail 3, would you be looking into graphene as a major component? And if so, what are the details? And if not, why not?
Yeah, who wants to jump on that one? Yeah, go ahead, Bruce.
I'll give just a general answer. One, reiterating, we don't have a plan for a LightSail 3. And
well,
two,
yes, as I said.
Kind of a general answer, which is, yeah, if we were doing another mission, we'd look back at, revisit all sorts of things. And the sail material is something that that you're always looking for something that's light and strong, and anything that's lighter. So I mean, Mylar was a convenient and good option, but with newer materials like graphene coming out, I think it would. I don't have an answer for you other than it would be certainly put into a trade space to try to figure out what the best thing is. We participated in a workshop that was tied to NASA and various solar sailing community people that actually talked about solar sailing and then how's that interface with metamaterials and all these exotic films.
Exactly.
And it was fascinating. I think it was illuminating for the metamaterials community learning about solar sailing, and solar sailing learning about metamaterials options. So it really opened my eyes to that certainly the future of solar sailing will probably involve more and more of these exotic materials. I don't know what the time frame is for that, because obviously you want something that's well proven and well trusted or tested out. So it's intriguing. So I don't have a more definitive answer, but I'd say yes, we would definitely consider other materials, including graphene.
Thank you.
Well, in the big picture, graphene is not inexpensive. We used this material because it was available. Its material properties were very well understood. But I've spent a little bit of time with graphene and its role. Years ago, I interviewed Rick Smalley. He was one of the guys who discovered buckyballs, Buckminster fullerenes. And he talked at length about the amazing potential of graphene and carbon nanotubes. And this could be another example where research into solving problems in space leads to remarkable technologies on Earth. Rick Smalley talked at length about the remarkable electrical properties of graphene and of nanotubes made of carbon, where you'd have transmission lines that weigh a sixth as much as modern ones with virtually no electrical resistance over many kilometers, and so on. So this is another example where, just in the big picture, where it's doing this research to make this extraordinary new type of spacecraft driven by a new type of propulsion may lead to remarkable technologies that benefit everyone. So there's a great question. Stay tuned. But right now we're using regular old Mylar that's very, very shiny. It is literally a factor of 2. If you have a dark sail, or if you had some black body of a sail, it would get so much momentum. If you have a perfectly spectrally shiny sail, it would get twice as much momentum because the photon bounces off and changes direction. So there's a great question. Stay tuned. Maybe we'll have graphene sails in the next 20 years and really, really advance space science. Thank you.
Oh, no, thank you. And I guess the only downside would be those who want to observe it as it goes by, since the reflection factor would be next to 0.
Well, plus you'd lose momentum. Do you follow me? Having a shiny sail.
Yeah, of course.
And so, but along that line, perhaps graphene sheets could be modified or altered or incorporate some metallic component that would increase its spectral properties tremendously. You know, who knows?
Yeah, that's a very good point because graphene is so friendly to interacting with other materials.
If you know it, apparently, you know, I'm not an expert, but I spent a little time. I wrote quite a bit about it, did some research. But never mind. Carry on. Back to you.
Thank you
so much.
Thank you.
Thank you.
And to ask a question, you can hit *1 to get into the Q&A queue. Do we have another question?
We'll now go to Doris Salazar with Space.com. Please go ahead.
Hello. My question is, did planetary protection policies affect the design of the spacecraft, particularly the sail? And I'm thinking especially in the big picture for future potential applications.
Bruce or Dave?
No, since we're just in Earth orbit in limited time and are already testing all sorts of other things for the first time, we did not consider planetary protection since there's no need or obligation for a spacecraft in Earth orbit that's going to burn up in any case. But obviously, depending on where you go in the solar system with your spacecraft, it may have to be considered in the future, but it also depends totally on where you go. Back to you.
Well, tying the last question to this one, you know, one of the dreams in the solar sailing community is to get to the round number of 100 kilometers a second of spacecraft speed relative to the sun, let's say. So in order to do that, you would have to have a spacecraft that could travel successfully very close to the sun and deal with the very high temperatures and high radiation environment near the sun. So if people really focused on this, perhaps we would be able to come up with a sail material and electronics that could tolerate or work properly in that environment. And that may lead to a material that could be sterilized by conventional heating, 165 Celsius or whatever, 165 Fahrenheit, 70 Celsius, where you just cook the thing to kill the microbes. Perhaps a sail design that could tolerate flying close to the sun would be suitable for a mission that required planetary protection because of the temperature involved. I mean, this is where one thing could lead to another. Back to you.
Thank you. I'll take the next question.
Our next question comes from Rachel Joy with Florida Today. Please go ahead.
Hey there, guys. So after so many years of developing this, you're certainly hitching a ride on a pretty exciting launch. Falcon Heavy's first nighttime launch and a very, very technical launch. So I think it's going to be pretty exciting. I'm curious what your presence is going to be here on the Space Coast, how many members you have coming out. You know, I'd love to know more about sort of what the membership is feeling overall, their sort of sense of excitement.
Yeah, this is Jennifer. Yeah, Jennifer, I can take it this. So we have a lot of excitement. Now, unfortunately, as launches go, we didn't get a lot of advance notice for this, but nevertheless, we have hundreds of members that we know of showing up to join the party with us. So we've offered a number of different activities, everything from really casual meetups so that we can just get to meet and greet people over dinner or drinks, to a free star party, to a gala dinner. And we have a mission briefing, a very low-cost mission briefing, so we can do something very similar with what we're doing with you right now with a much broader group of hundreds. So we're excited to be there with the people making this happen. And of course, we have literally tens of thousands of others around the world who will be celebrating at home or in small groups, doing launch parties. We're trying to do everything we can to get all eyes on that Falcon Heavy. And everyone's screaming out, "Go LightSail." Back to you.
And as a reminder, that is Thank you. And as a reminder, that is the star and 1 keys to ask a question. And we'll take a follow-up from Daniel Oberhaus with Wired. Please go ahead. And Daniel, your line is open. Please go ahead with your question. We will next go to James Maynard with the Cosmic Companion. Please go ahead.
Hi there. Thank you very much for taking my question. And I want to say I'm very excited about the whole LightSail program and have been for years. Take a look at the future of the LightSail program, and I'd like to know how each of you might envision this technology being used in the future, not just for serious applications like, say, bringing cargo to planetary colonies of the future, but also possibly even recreationally in the way, for instance, that people may have sailboat races today.
Well, Carl Sagan talked about regattas, having sailboat races between the Earth and some other solar sail spacecraft races between the Earth and other destinations in the solar system. But that sounds like a long way off to me. However, the whole idea of LightSail 2 is to democratize space. So perhaps a standard solar sail package will emerge the same way they have standards in sailboat racing, where the standard boats with standard size sails, standard crews. Maybe that would take place. The key will be getting these spacecraft in Earth orbit, and of course there'll be some traffic control issues. But just that we're talking about it, to me, is very exciting. That we can imagine a solar sail so inexpensive that we'll have a race. Who can operate? Who can they control the pitch yaw and roll of spacecraft well enough to optimize its orientation to the sun and win a race? It's a very cool idea. That goes back, for me, it goes back to when Carl Sagan first brought it up. The thing that's interesting, any way you look at it, is just that it works so much like a sailboat. Here comes the photons from the sun, the same way molecules of air move through the wind, and you orient the sail so that to take best advantage of it. Oh, and by the way, the solar wind is not really what we're exploiting here, everybody. That's about 100 of the photons themselves. It's really a surprising thing. You know, photons have no mass or no rest mass, but they have momentum. It's really a surprising thing. So to your point, James, the answer is absolutely, without question, maybe. But it's a ways off. Back to you.
All right. Thank you very much. Appreciate that.
Do we have another question?
That is the star and 1 keys if you would like to ask a question today. We'll pause a brief moment to allow any further questions to queue. We'll take a follow-up from Daniel Oberhaus with Wired. Please go ahead.
Hey, thanks for taking my next question. I was hoping you could just briefly compare the kind of technical specs of the LightSail with the Icarus spacecraft that was launched about a decade ago. I understand the Icarus is quite a bit larger, but aside from that, are the fundamentals the same?
This is Dave. I've got some of those numbers here. So the Icarus sail area was 196 square meters, and LightSail 2 is a 32 square meter. So that's about 1/6 the size of Icarus. But Icarus was a much larger spacecraft. It had a spacecraft mass of 307 kilograms, and the spacecraft mass of LightSail 2 is just 5 kilograms. So the whole game in terms of solar sailing is that area to mass ratio. And LightSail 2 has an area to mass ratio of about 6 in terms of square meters per kilogram. And that's very efficient from in terms of the solar sails that have flown to date.
In a sense, LightSail 2 is higher performance. I mean, in this sense, than Icarus. But Icarus was just a cool mission. You know, it's still out there. And the thing that struck, I've been to Japan a couple times now, and at the Solar Sail Symposium, you meet the Japanese engineers who are involved in this. And they really do hold up the sail. The Japanese sails, JAXA rather, Japanese Aerospace Exploration Agency sails are really derived from origami. It's fascinating. It's so much a part of their engineers' upbringing. You know, whereas LightSail 2 is folded in I think an intuitive way, and certainly would learn from each other. But the Icarus sail was deployed by spinning, and that's cool, and it worked great. And they even did some maneuvering by dimming the reflectivity of the sail with liquid crystal panels embedded in the sails. But that type of steering is too slow for Earth orbit. You couldn't maneuver a system like Icarus in Earth orbit effectively to get increasing orbital energy. And the bus, or the main part of the spacecraft, was just quite massive compared to the sail, because that mission is going to Venus to do research at Venus. It wasn't a demonstrator for Earth orbit. Really, it's really a great mission. Icarus is really a great mission, but in the solar sailing sense, LightSail 2 is just a higher performance. It's part of advancing this technology. Back to you,
Bill. Just to add on to that, one bit, because I'm looking at the numbers here. LightSail 2 has the highest characteristic acceleration of any solar sail that's been flown to date. Characteristic acceleration is a parameter that's used to compare solar sails. Basically, it's how much acceleration the sail would get at 1 astronomical unit from the sun. So basically, at Earth's distance from the sun, if it's face on to the sun direction. And LightSail 2 is the highest performing solar sail that has flown to date. NeoScout, when it launches in 2020, will surpass LightSail 2. But for the time being, once we fly this thing, it's going to be the highest performing solar sail to date.
Yeah, it's about 6 times the characteristic acceleration of Icarus. About 6. It's excuse me. Yeah, about 6 times. Yeah, 6 times. So it's exciting.
Does anyone else have anything to add? Okay, we'll take another question.
We'll now go to Annie Wilson with CosmoQuest. Your line is now open.
Hi, thanks for taking my call. And one of my community members asked if there were any other redundancies aside from the manual timer and the software timer to the spacecraft.
And it does appear that we have no further questions at this time.
Excellent. All right. Well, thank you, everyone, for joining us today. A recording of this teleconference will be made available in our LightSail press room later today. That's at planetary.org, and look for our press room, and you'll see it there. Alongside the recording, we have photos, infographics, videos, background information, up-to-date information, so that's all to be found at planetary.org. We hope you can stay tuned for the launch of LightSail 2 on Monday, June 24th, starting at 11:30 p.m. Eastern. And if you're coming down to the launch, please get in touch with me, as we have other opportunities for you to speak with Bill and the mission team in Florida that we're preparing. And so you can reach out to me directly at danielle.gunn@planetary.org. And I think I've emailed with most of you, but if you can't find my email address, it's also on our website. If you need anything else, any follow-up for your storytelling, just let me know. And again, thank you very much.
This does conclude today's program. Thank you for your participation. You may disconnect at any time.
So, I tried. No journey started. What happened was I have myself muted in a gazillion places because I did not want to disrupt the conference. And I had myself muted in VoiceMeeter. I had myself muted on Google Voice, and I asked the question and you guys heard it, but they didn't because I had myself muted. And because I didn't want feedback into that thing, I had muted them, so I couldn't hear them and they couldn't hear me. I tried. I am so sorry. A lot of you guys had really good questions. I think a lot of them were answered, and I think some of them can be answered by just us doing some research on LightSails, because I know like still zero things about LightSail. So I tried. But I did make, while they were talking, because I also wanted to make sure that I wasn't asking a stupid question that somebody else was asking. I did make molecules. So this was a mylar, which is what the sail is made out of, and I had demonstrated some graphene because one of the earlier callers asked about graphene, and essentially graphene's not shiny enough. That's essentially it, is graphene's not shiny enough. I don't know if it's what it is about mylar that makes it shinier than graphene, because graphene is essentially this benzene ring without all the attachments, including the hydrogens. And I mean, there's a lot of extra stuff on this, so it might be the hydrogens, it might just be the fact that this is a very rotating, non-rigid structure. Meanwhile, graphene is kind of a rigid structure. So they took a lot of words to say not shiny, essentially. So, mylar has aluminum? I don't know. I looked up mylar, and that was one of the units for it. So, yeah. If they want to make an extra shiny sail from carbon, why not make it out of diamond? I know, right? So, thank you for tuning in. Thank you for your patience. This was a really long teleconference. And, it's aluminum over plastic. So that might be the plastic backing. Okay. And now my desk is just a mess of molecules and bits and pieces. So, yeah, thank you everybody for tuning in. I know things were a little different today, but that's okay, because special things. There is a launch later tonight, probably in a few hours. I am going to take this opportunity to take a break and spend some time with Favorite Human, who has so gracefully holed himself upstairs. So he does not interrupt. He's come down here and stood by me twice and just stared. And he could tell I was staring intently at the screen and listening. So, yeah, 2100 UTC, so 21 minus 4 is 17, which is 5 p.m., and it's 2 p.m. Yeah, I'm going to take a bit of a break. I'm going to run out of the house and see what the outside looks like, and then we'll be back. So I should be back by 4. Oh my, this is going to be a run out of the house and a run back in the house kind of day. Yeah, he's missed me. So, yeah, I will see you guys in a couple hours, and all of that. Have a wonderful insert time of day here. Very quick wall of text, since, you know, things and stuff. First of all, we are brought to you by you, so thank you everyone for all of your support, for inflicting us upon your friends, families, and colleagues, for your financial contributions, which allow me to collect a paycheck from doing this. So thank you all. I really, really do appreciate it. Was he staring at you like how the dogs are staring at the screen? Asked Hanny. Yes, actually, he was indeed staring at me like how Tinker is staring into the webcam and stealing all of your souls. I don't have any more bits. You know what? I have a dog treat. Tinker, what will you do for this? Will you sit? Will you speak? You want this dog treat. Do you want the dog treat? See? 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 Can you come get it? Come here. Really? She's like, okay. She actually likes those dog treats. See? Her tail is wagging. Oh no, now I have to give the other dog a treat. Come here. Come here. Can you get up? Can we do it? He's like, yes, if you help me, Mom. Okay, will you take this dog treat? Because I ran out of Cheerios in my container. Crunch, crunch, crunch. Oh no, he dropped it. Okay, off. Off, so you can get your treat. Right here. No, no, it's Puck's treat. You had a treat. There you go. And he's gonna run away with this treat. Do you know which muscle is more developed in dogs and wolves? Yes, the muscles around their eyes. It is indeed the muscles around their eyes, so they can have more facial expressions. And yes, it is the surprisingly large dog. He's actually not that big. He's 25 pounds at most. No, I don't know how many soda liter bottles that is. All right, so along with the wall of text, this was a production brought to you, aside from you guys, who are amazingly awesome, PSI. PSI is Planetary Science Institute, our host institution, and we work in collaboration with Youngstown State University in Youngstown, will it ever stop raining, Ohio. And I think that's it for the really short things. We archive everything on YouTube. If you're watching this on YouTube, you missed out. And we stream Sundays through Fridays at 1 p.m. Eastern. Right now that's 1700 hours UTC. So, yeah, yeah, I think that's all. I'm going to awkwardly roll the credits because that's how we do things, and I have a gazillion windows open, and I might not even have the credits open at all. Oh, I do. It's in this window. And we're just gonna let AutoHost take over, because unless somebody comes up real quick with somebody to raid. But yeah, thank you all for tuning in and listening in with us. This was good. This was fun. And yeah, I will see you later. Das, if you give me Das's username, because I can't ever remember his username. Yeah. And that's it. Bye. Transition.